Okay. Here we're going to solve the same equation using the second method. Here you'll appreciate the second method rather than the first one, and you will understand why this method is actually easier with using a difficult, or you can say further bit more complex problem. Okay, let's start. I will explain from the beginning. It has the same basic steps. Just the change is with the boundary conditions, but I'm going to explain from the beginning. Maybe you would understand here. So starting with the assumption. What's the assumption? The assumption is using the first equation, or the first variable with the variables below. This will give you u, use the capital letters, with the lower variables. There are x and t. As I said this before, some books might indicate it as this following symbol. You can actually use any type of symbols that you want. You can use X in this form and T in this form, but don't go creative. You're not a painter. You're not an sort of an artist, unless if you are, but just keep that aside. Okay, just to check if I'm recording. Okay, I'm recording. Okay. Now we're going to apply this on the equation here. So partial for this one, partial square u over partial x square. This will be equal to differentiating u to the respect of x twice. This will give you x double prime t. As for the other one, partial square u over partial t square, you need to differentiate to the respective t of the function u. This will give you x t double prime. Now substituting these values here in the equation given, or the problem, this will give you that x double prime t is equal to c square x t double prime. Okay. Now you need to divide by the assumption. Remember this step, divide by the assumption. The assumption again is x and t. This will give you this x double prime over x equals c squared t double prime over t. Now that seems like a song, but it's not. These are all equal to lambda. Now here you need to split your page into two. Why I wrote this here, I would write it down there. Okay. Now you need to split your page into two. X double prime over x equals lambda. C squared t double prime over t equals lambda. Multiply with x. X double prime equals to lambda x. Then lambda x is equal to 0. Here, multiply with t over c squared. Remember, you want to keep the differentiated parts without any factors. Okay, or just with the factor of 1, no other factors. So this will give you t double prime lambda over c squared t. Take it to the other side. This will give you t double prime minus lambda over c squared t gives equal to 0. Now these both are our first solutions. Now we want to extract 3 solutions from them using the 3 cases. Using case 1, case 2, case 3, case 1, starting with case 1, the most basic one, lambda is equal to 0. This gives you x double prime is equal to 0, since this can be cancelled and this term would be cancelled due to the lambda. Okay, by integrating this twice, you'll get x prime is equal to c, x is equal to c1x plus c2. Same thing here, t double prime is equal to 0. T prime is equal to c3. T is equal to c3 t plus c4. Now finally, not finally, there's no finally here. We're still pretty much far from finally. You can go with u xt is equal to the multiplication of this function multiplied with this. This will give you that just by distributing the values. C1x multiplied with C3t will give you a xt. Then C1x multiplied with C4, this is equal to bx. Now C2 multiplied with C3 will give you CT. C2 multiplied with C4 will give you just a normal constant, which is D. Okay, this is the first solution. Okay. Now going to case 2, lambda is equal to positive beta square. Okay. This gives you that x double prime minus beta square x equal to 0. X is equal to C1e to the power beta x plus C2e to the power negative beta x. Okay. Just guys, can you tell me if the doctor will provide you with the formula sheet to find these? Do you know that for certain? Did he tell you anything about it? Do you know? He didn't mention anything. Okay, that's bad. Okay. See, I will derive. Do you remember differential equations? Hopefully you do. I will show you this in detail. I showed you this in the first recording, but I will go through it in detail. You don't have to do that if you memorize the cases. Personally, I do not memorize them well. You can go with my method if you do not memorize and there are no formula sheets. So from differential equations, you can go with m squared, since we have a second order, minus beta square remains the same. X is not differentiated, so it's basically to the order 0. So you'll not place it here. Okay, equal to 0. Solve this, take this to the other side, will give you m plus or minus beta. Take it to the other side, then take the square root for both sides. Do you understand this? Hopefully you do. Here for the same function, for the other equation, t double prime minus beta square over c square, t is equal to 0. Using the same method, m square minus beta square over c square is equal to 0. M, take this to the other side, then square root. This will give you plus or minus beta over c. Now these both solutions, remember it from differential equations, that I'll show it to you. Duration. When we have a value of m unequal m, this is which is our case, but we just have different ones. You will get this. This is your homogeneous solution. When you get this, in our cases, alpha is always equal to 0. But when you get this, you'll get to use C1 cosine beta plus C plus C2 sine beta. Just you need to remember these two. These are the only things that you need to remember. Remember, not memorize. You must remember these. You must already memorize these from differentials. So this will give you that x is equal to C1e to the power beta x plus C2e to the power negative beta x. Here, t is equal to C3 e to the power positive, or there are no positive, beta over C t plus C4 e to the power beta over C t negative here. Now we need to find the value of u, which is also the assumption, x multiplied with t. Multiply these two. We are having constant by constant, so that's a, then e, because we have the same base. Then find the summation of the exponents, beta x plus beta over ct plus b, since this one multiplied with this, same base, different exponents, so just find the summation again, beta x minus beta over ct. Now this, for this term, plus c, as a constant multiplied with a constant, e, same base, negative beta x, plus beta over c t plus d e negative beta x minus beta over ct. Okay, this is our second solution. Now going to third solution, case 3, lambda is equal to negative beta square. This will give you, after splitting the page, the most important thing to do. This will give you x double prime plus beta square x is equal to 0. Here t double prime plus beta prime over c squared t is equal to 0. Now using differential equations, if you want to, or just memorizing the cases, m square plus beta square equal to 0. This will give you, take this to the other side, you can get m square negative beta square, square root for both sides. You'll get m, since we have a negative, so we'll have an I. Square root of negative 1 is equal to I. Got this in chapter 2. And beta, positive or minus. Here, we'll get the same thing. Beta square over c square equal to 0. Take this to the other side, m square negative beta square over c square, square root both sides. You'll get m is equal to plus or minus I beta over c. So finding the solutions, remembering since we have a complex solution, this will give you that the value of each function is x, c1 sine, beta x plus c2 cosine beta x. As for t, c3 sine beta over ct plus c4, this is a t, c4 cosine beta over ct. Okay, now multiplying the x and t, and you will get, we'll work on it like before, you'll get a sine beta x multiplied with sine beta over c t plus, again, this term with this term this time, b sine beta x multiplied with cosine beta over ct. Now this term plus c multiplied with this one. Okay, c sine beta x sine beta over c t. Again, that term multiplied with this term will give you d cosine beta x cosine beta ct. Now, okay, finally we had the three solutions. Now we need to use the boundary conditions here. That you can see that my method is different. Finally, the boundary conditions. BC's. Now I want you to understand the boundary conditions 100%. Here, as for this first one, can say our most important one, u of 0 and t. Remember that the main function is u x of t. This means 0 and x. This means that x is x of 0. Since u of 0 of t is equal to 0, this will also be equal to 0. Do you understand this? So you can just change this u of 0 of t, u of 0 and t can be changed to this. The same thing for the other boundary conditions, u, l, and t are also important boundary condition. This can be changed to x, l of 0. L equal to 0, sorry. X of L is equal to 0. Okay, now this is an extremely important step in my method. Again, my method is a mix of like 3 methods I got from a bunch of them from YouTube, the others from the doctor, and just mixed up to get this method simplified for you. So you got these, okay? Now, instead of using the solutions the U solutions that we got, instead of using this and going all messy, and this, the long, difficult, weird one, and this that needs common factors and messed up things, you can just go with the x's, okay? So I will start with the solution of x, the first one, case 1. Okay, this will give you, okay, this is correct, nice. Starting with case 1. Okay, this is case 1. Now using the new boundary conditions that you obtained, just remember, what's the variable here? This is a variable of x. This one is originally an x. So x of this number, 0, is equal to the same, 0. So if you're working on a system of, let's say, y is z and x, and you got the boundary condition of y of 0 and x, this gives you that z of 0 is equal to whatever this is equal. Okay, do you understand this? Please, hopefully you're understanding what I'm saying. Okay, this is so normal. Do you understand this? Hannah, send me a thumbs up. Thank you. That's very annoying. Okay. Now this is our case, and you're going to use the new boundary conditions. X of 0 is C1, 0 plus C2 is equal to 0. Now you can see that this term is cancelled now. So this gives you that C2 is equal to 0. Correct? So this means that for the original function, C2 is useless. It's just C1x. Now using the other boundary condition, x of L, C1 L is equal to 0. This means that C1, remember, L is not equal to 0. It must not be equal to 0. Please remember this. So this means that C1 is equal to 0. For a non-zero number must be equal to 0, you must multiply it with a 0. Okay, so since you have C1 and C2 are equal to 0, this solution is rejected. Okay? Now going to case 2. And instead of using the U solution, we can go with this. Okay, now using the boundary conditions, you can actually use this method on the first question I showed you, and you have another recording on it. So if you want to check it, it's only like 19 minutes, so it's not a long one. You can just review it. Since you know it from this question, you might figure it out by yourself for the another question. Okay, so x of 0, C1, e to the power 0 is 1, so I won't write it plus. The same thing here, C2 is equal to 0. This gives you that C1 is a negative C2. Okay, now if you want to, you can just rewrite x C1e to the power beta x minus C1e to the power negative beta x. Now x of L, then the second boundary condition, C1e to the power Lx minus C1e to the power negative Lx equal to 0. C1 and C1 can be cancelled. This gives you the indication that since we have a negative here, you can take it to the other side. I'll write it first. Lx, Lx equal to 0. This can be changed to Lx equal to negative Lx. Does this make any sense? If it does for you, that's a big problem because Lx is not equal to, since we have a negative, it's the reciprocal. Does this make any sense for you? When you have, let's say, 1 over 4, is it equal to 4? That's the same thing here. That's exactly the same thing, but the same concept. Okay, so for these two must to be equal, C1 must be equal to 0. And since C2 is equal to negative C1, this also says that C2 is also equal to 0. Since C1 and C2 are both equal to 0, you can say x is equal to 0, hence the value of u is all equal to 0. The same thing here, actually. Since x is equal to 0, u is equal to 0. So 0 multiplied with anything, it is just a 0. You can write it in detail here if you want to. Since x is equal to 0, u, x and t, 0 multiplied with t is 0, whatever the value of t is, whatever the function of t is. Same thing here. Since x is equal to 0, u, this is just a clarification to the doctor that you understand what you're doing. Okay, 0. Okay, now jumping to case 3. Now, instead of using the whole this, you can go just with this. Okay, why I didn't show you this before, and instead of mixing you up with two methods, the doctor asked me to do that. Okay, he asked me to show his method only, but I wanted to help you and to show you another method that might be far more useful for you. Again, the doctor's method is the academic way, the smart way, but you can go with my way, it's fine. X of 0. This gives you that C1 sine 0 plus C2 sine 0. Sorry, cosine 0 here. Cosine 0 is equal to 0. Simplify this. This is cancelled. C2 is equal to 0. Cosine 0 is equal to 1. Remember this. So since C2 is equal to 0, the new function is just x, C1 sine bx, beta x. Now for the second boundary condition, C1 sine beta L equal to 0. Cancel the C1. You will get sine beta L equal to 0. Now for sine beta L to be equal to 0, beta L must be equal to n pi. Beta is equal to n pi over L. Now going to Fourier series solution, Bn is equal to integration from 0 to L, B of 0, or B naught, sine n pi L, or the value of beta, dx. Now going to the boundary okay, this is not relevant. Okay, now going here. 10x. Going to use this. Remember, when t is equal to 0, we're getting b naught. Okay. So 2 over L, 0 to L, 10x sine n pi over Lx dx. This is equal to 20 L 0 to L x sine n pi over Lx dx. Now use integration by parts or tabular integration. I'll use tabular. I hate integration by parts. Sine n pi over Lx. Now the integration of sine is negative cosine. So we get the reciprocal of the factor of the variable x. Negative sine, cosine, and pi for Lx. Now the integration of cosine is sine, and we already have the negative. So yes, this will give us L over n pi square sine n pi over Lx. Okay, plus and minus. This will give you that 20 over L integration 0 to, there's no integration, sorry. We already integrated. 20 over L negative XL over n pi cosine n pi over Lx minus LN pi square sine n pi over Lx. The interval is 0 to L. Now from Fourier series, we remember that at whatever sine term you get, you can just cancel it. Because if you substitute the value of L or 0, you'll eventually get it cancelled. So you will end up with 20L negative XL over n pi cosine n pi over L x. Now get the constant out. You'll get 20 over n pi negative. This will give you x cosine n pi over Lx 0 to L. Just substitute the values. 20 and pi L cosine. So if you substitute the value of L inside will be n pi minus 0 due to the x, since there's an x multiplied. This will give you that negative 20 over n pi. This is simplified to negative 1 to the power n, and L is just a constant, power n here. Okay, that's the value of Fourier series. This is the computation of Fourier series. This will give you that u of x and t is approximated from 0 to infinity This is a messed up infinity. This 20 over n pi negative 1 to the power n sine n pi over Lx. Okay, this is the solution of this wave equation. Now, by judging, it's almost the same, just with the difference of the boundary conditions. You can see that the boundary conditions are a bit easier here for you to follow. Okay, do you have any questions? This is it. That's the whole thing. Do you have any questions? Guys, do you have any questions? Okay, clear.